Okay, this is the second goal of 4-8 quadratic inequalities. I would like to go over some situations with you and kind of explain what we're doing with this part of the section. First of all, this part of the section is not just graphing, it's solving. And if you remember what we've been doing, or if you're familiar with what we've been doing in the past, solutions of a quadratic are where the graph crosses the x-axis. So if this is the x-axis and the graph crosses the x-axis here, these typically then are the solutions. Let's call that solution A and solution B. Now, those are the solutions, the x-intercepts. Now, when you're graphing an inequality, you're going to have infinitely many solutions a lot of times. Now, for example, situation A. All right, so the situation A is a solid line, so it crosses the x-axis at these 2 points, but it's also shaded in between. So any point in between these are also x-intercepts. Okay, so let's just say that this one is 2 and this one is 5. Okay, so this number is 2, this number is 5. The solutions of a situation like this are everything from 2 all the way up to 5. So x is anything between 2 and 5. Now, you could write this using interval notation, which of course would be everything from 2 to 5. You could do it that way as well. Okay, the second situation again is having a parabola cross the x-axis twice. Okay, this time it's got 2 open circle points because it's a dotted line. And so if that's the situation and it's everything in between, you actually do not include the 2 points that the graph itself or the parabola itself crosses. So let's say this is -3 and 1. Okay, so if this is -3, this is 1, x is not equal to -3 or 1, but it is everything in between. So everything in between would be from -3 less than, or x which is less than 1, or you could say everything from -3 to 1 with parentheses, because remember with interval notation, parentheses signify not equal to. Okay? All right. In this situation, again, we have a parabola. It's inside the parabola, so the graph is inside. Now, the parabola itself does not cross the x-axis. So, if you look here, anywhere on the x-axis, there are no points or highlighted or shaded regions. So in this situation, there is nothing that is intersecting the x-axis. So in this situation, there is no solution. Okay, situation D. This time I put the graph on the outside of the parabola. Again, we have 2 points that are crossing. Let's say this is -2 and 0.5. Okay, everything outside of the parabola is shaded. So that means all your x-intercepts are outside the -2 and 0.5. So this time, x is less than or equal to -2, or x is greater than or equal to 0.5. Now, in interval notation, you would say, okay, well that's everything from -infinity all the way up to -2 bracket, because it's equal to, union bracket 0.5 all the way up to +infinity. So that's interval notation on this one. Again, on this one, it's almost identical, except in this one you have open circles. And so let's say this is -1 and 4. Okay, everything outside of -1 is shaded, everything outside of 4 is shaded. So everything goes from x is less than, this time, -1, or x is greater than 4. This time you'd go -infinity up to -1. parenthesis, because it's not including -1, union parentheses 4 to infinity. So there's your interval notation. Now, this situation, the parabola does not cross the x-axis, but the shaded region covers all of the x-axis because the shaded part, or all of the x-axis, is shaded. So in this case, it would be all real numbers. Or you could say everything from -infinity up to +infinity. So all of the solutions are possible there because everything is shaded. Okay, let's do a couple example problems. I've got them written over here on the other side of the board. Okay, so here you're given a quadratic inequality, and it's asking you to solve by graphing. So just like we graphed in example 1, we're going to graph these as well. All right, so this first one, however, here is not quite as important to find the vertex. All you're really worried about in this case are the x-intercepts and the shaded region. Okay, so this again is like y is greater than x squared plus 5x minus 6, okay, because 0 and y are interchangeable. So what we're looking for is the graph and where it's above the graph, shaded above the graph, okay? So what we're going to do here is I'm not as worried about the vertex, but I am worried about the x-intercepts. So I'm still going to make a table, but I'm going to look for the x-intercepts instead. Now, however I can do that, if it's quadratic formula or factoring or anything like that, I'm going to use that. So I'm going to use factoring to find my zeros. So if I use factoring, x, let's see, plus 6, x minus 1. So x is -6 and +1. So -6 is a 0 and 1 is a 0. Okay, so on my graph, I'm thinking, okay, -6 here and 1 here are zeros. And it's not equal to, it's just greater than, so they're open circles. But let's figure out, is it shaded inside or outside? Well, we need to know how the graph is shaped. Does it open up or does it open down? In this case, if y is greater than a positive a right here tells me that the graph opens up. So I know the parabola is going to look like this because it's a positive a. Now, y is greater than means it's above the graph. That tells me that the shaded region is inside the graph because it opens up and it's above. Now, that also then tells me that it's everything in between that's shaded. So my solution to this one is everything in between -6 and 1. That's interval notation, or you could say x is greater than -6, x is less than 1. So I'm using a graph, but I'm not necessarily graphing it completely. I'm just using the intercepts, how the graph is shaped, and then of course where it's shaded. Is it shaded in between the two intercepts or outside the two intercepts? Okay, let's do this one. This time we have -x squared plus 3x plus 10. Again, you can use a table. You can plug this in your calculator. You can find out what the intercepts are. If I plug this into the calculator, I end up with -2, 0, -1, 6, 0, 10, 1, 12, 2, 12, 3, 10, 4, 6, and 5, 0. So that table on my calculator tells me exactly what my graph looks like. Where the zeros are happens to tell me that. And so my zeros are through -2, and I look at my sign here. My sign is equal to, so that's a solid dot, and 5, which is right there. Now, if I were to graph this, I look at my A value. My A value is negative. This tells me that my graph is opening down. I'm not going to be real worried about exactly how my graph shape is, but I am concerned with whether it opens up or down, because when I look at this sign, now you got to remember this sign is on the back side. So this is like y is greater than negative x squared plus 3x plus 10, because if I move the 0 to the left side, I have to flip that sign over, so it's greater than, which is on the outside. What does that tell me about my solutions? It tells me my solutions are everything to the outside of negative 2 and 5. How does that tell me how to write my answer? Well, my answer then is my solutions are x is less than or equal to negative 2, or x is greater than or equal to 5, or I could write it as interval notation, which is negative infinity all the way up to negative 2 bracket union bracket 5 to infinity. Now, if you're unsure whether you shaded it correctly, but you know you've got the two intercepts correctly, again, just check an answer. If I put 0 in for x, do I get 0 for y? Okay, or excuse me, if I put 0, 0 in for x and y, does this side less than this side? So in this case, I have, if I put 0, 0 in, all right, if I put 0, 0 in, I've got 0 plus 10. Is that less than 0? And that's no. 0, 0 is a no, so that should not be shaded. So I know I've got my shaded region correct. And you can always double check your answers. You can constantly be double checking your answers to see if you've got the shaded region right, you've got the zeros right, the endpoints of your inequality. All right, let's do a couple more. I'm going to erase this side. Well, actually, I'll erase the whole board so I can put on some more examples here. Okay, so example 3A in the book is x squared minus 6x plus 2 is greater than 0. 3B is negative 4x squared plus 5x plus 7 is greater than or equal to 0. Okay, so the difference between these problems and example 2 problems is the fact that these are not just nice answers. They're going to be, irrational solutions. And so what I'd like you to do is practice your quadratic formula. And that's what I did when I did these. So let's go ahead and start with this. Now, remember, we're looking for, on the graph, we're looking for our zeros, our where the graph actually crosses the x-axis. So what I'm going to do is I'm going to take this part and I'm going to use the quadratic formula to find my answers. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Positive 6 plus or minus 36 minus 4 times 1 times 2. That would be 8 over 2, which is 6 plus or minus the square root of 28 over 2, which is 6 plus or minus 2 square root of 7 over 2, which is 3 plus or minus the square root of 7. So these are my x-intercepts. Now, my axis of symmetry is actually at 3. My two x-intercepts are 3 plus the square root of 7 and 3 minus the square root of 7, because you're adding and subtracting the square root of 7 from 3. So those are your two intercepts. They're open circles because it's not equal to. Now, if I were to actually graph this, again, I'm not going to worry about the vertex exactly where that is. All I have to know is, does it open up or down? And because A is positive, it opens up. So I'm going to just go ahead and draw a parabola opening up. Now, this time, I'm not going to worry about moving the 0 over. I'm going to use a little bit different concept here. I'm going to say, okay, this is the parabola. Where is that greater than 0? Where is that above 0? Well, the graph above 0 is on the outsides of those two, because these parts are above 0. So I know the x-intercepts are everything outside of these 2 points. So let's go ahead and write our solution. So in this case, our solution is everything outside, so x is less than 3 minus the square root of 7, or x is greater than 3 plus the square root of 7. And again, interval notation, you could say negative infinity all the way up to 3 minus the square root of 7, parentheses, union, 3 plus the square root of 7 all the way up to infinity. Okay, again, the graph opens up because A is positive. These are my two intercepts. Those are my two solutions. And then we have to figure out, is it shaded outside or inside of those? And we figured out, because it opens up and it's where it's greater than 0, is above or outside here. And so those are my solutions of this inequality. Let's try the next one. Okay, now let's go ahead and go with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals, we have negative 5 plus or minus the square root of 25, and it ends up to be a plus. I have it here somewhere. 112 over negative 8. So x is equal to, it actually, you can cancel those negatives, so 5 plus or minus the square root of 137 over 8. Those are my two solutions. So my two solutions are, and if you estimate what those estimated are just under 0. It's like at approximately negative 0.84 and approximately 2.09. And so it's right in here and right in here. Those are my approximate answers. Now, this time my graph opens down because the A is negative, so it's going to look like this. Where is the graph greater than 0? The graph greater than is in between, because that's where it's above the x-axis, so it's right in between. So now all I need to know is my two solutions. My two solutions are 5 minus the square root of 137 over 8 and 5 plus the square root of 137 over 8. It's everything in between those. Or again, you could write it as x is greater than or equal to 5 minus the square root of 137 all over 8, or less than or equal to 5 plus the square root of 137 over 8. Or you could use the decimals, but you should know how to write it in simplified radical form if possible. Okay, I got two more. They want you to, I'm going to jump to example 5, and they want you to use algebra to solve these. So I'm going to try to talk you through algebra, but we're still going to use kind of the basics of graphing to help us understand it. Okay, so 5a, we have x squared plus 5x is less than negative 6. So we're using algebra here, and so what I'm going to do again is just try to find, I'm picturing in my head, here's the x-axis, I'm picturing in my head what these two solutions are. Okay, and again, I'll just draw it correctly. They're supposed to be open circles because it's not equal to. So what I'm going to use is I'm actually going to use factoring. X squared plus 5x plus 6 is less than 0. Okay, so I'm going to use factoring here. X plus 2, x plus 3. So x is negative 2 and negative 3. So here's negative 3 and negative 2. Now, all you really have to do, you don't necessarily, you can use graphing like we did in example 3 and using the common sense there. But if all we do is we take a point, we know that it's either going to be graphed in between these or it's going to be graphed outside of these. Okay, it's not going to be one or it's not going to be a combination. It's going to be one of these or the other. Okay, so what I'm going to do is I'm going to pick a point. Pick a number, x equals 0, for example. Okay, so 0 is right out here. So I'm going to pick 0 here. If that works in the original problem, then I know it's the outside of those 2 points. If 0 does not work, then I know it's between those 2 points. Okay, so I'm going to use the original problem. I'm going to put 0 in. Is 0 less than negative 6? And the answer is no. So the only possible way this could work is by having it in between these. So I know that these work because 0 does not work. So my solution is negative 3 is less than x, which is less than negative 2. Or, of course, negative 3 to negative 2. Okay, so those are that's my solution. So all I'm doing is exactly the same thing. I'm finding my zeros, but then I have to know if it's shaded in between or outside. Since 0 does not work and that's on the outside, it has to be on the inside, all the answers that work. So let's use that concept in 5b. Okay, so x squared plus 11x plus 30 is greater than or equal to 0. Again, we're going to use factoring because it does factor. X plus 5, x plus 6, x equals negative 5 and negative 6. So again, I'm picturing in my head, here's negative 6, here's negative 5, solid dots. Is it between? Or is it on the outsides of these? It's one or the other. It can't be both. So therefore, let's go ahead. Well, I guess it could be depending on, but we have 2 solutions. So we know it's going to be one or the other. All right, so let's go ahead and try this. Let's pick a point. Again, I'm going to pick 0. It's just really easy to use. I'm going to pick 0 here. And does it work? Does 0 work? Put 0 in. 0 squared plus 11 times 0 plus 30. Is that greater than or equal to 0? I've got 30 is greater than or equal to 0. Yes, that works. So I know that these are the solutions to this inequality. Okay, so I have negative infinity all the way up to negative 6, union negative 5 all the way up to infinity. Now, I made a mistake because I did not put brackets, because this is an equal to one, and remember, if it's equal to the number, you gotta have brackets. All right, there's my solution set. That's how you do it using algebra. I'm still kind of using a graph just to understand it and to picture it in my head because I understand that, but it helps to be able to find the intercepts using algebra, since we've learned a lot of that as well. Good luck. Let me know if you need help. And that's all I have for you for this section.